So we've reached the third exponent law, product of powers. Remember, a power is a base with its exponent together. That whole thing is called a power. So we're going to go through products of powers. Let's start by taking a look at this table. We're going to fill it in. You're welcome to work ahead, pause, rewind as needed. I filled in the first row for you so you have an idea of what we're doing. What I did was I took 7 cubed and I wrote it out. 7 cubed means 7 times 7 times 7. A lot of the times we don't write it out this way. Then I did 7 squared. Now those two things are being multiplied by each other. So when you see the expanded product and you count the number of factors, remember factors are things being multiplied. There's 5. So I can rewrite that as a power now, and that's 7 to the 5th. So let's go down and do 2 to the 4th. When I write it out, I should have 4 2's times 4 2's. When you count the number of 2's there, you should have 8. So you have 2 to the 8th. Does everyone see how we're doing this? You can do the same thing with variables. Because remember, a variable is a number. We just don't know it yet. So I'm going to write out, I have x to the 4th, which means I'm going to have 4x's times 5x's. So when you count the total number of x's, you have 9. So you just write x to the 9th. That is okay. We'll do the same thing with m. We're going to write it out. I'm going to go through, I'm going to count the number of m's written, and you should have 6. So that would be m to the 6th. So now we've done 2 number bases and 2 variable bases. The change here now is instead of 2 powers, I have 3. That doesn't change anything I'm doing. I still do the same exact thing. So I'd have 3 squared times 3 to the 4th times 3 squared. Expand it out. I count my number of 3's. There are 8 of them. So you write 3 to the 8th. Again, same thing with variables. We're going to expand out my power. I'm going to count how many y's there are. Then I'm basically going to condense down my product to y to the 9th. Now, this is something you can do all the time. But let's take a look at this. Let's look at the table as a whole. Do you notice something about the base from the first column to the last column? You should have said the bases are the same. Perfect. What do you notice about the exponents? The exponents from column 1, the first column, to the last column. The exponents are added. That's how we got the last column from the first column. So do you think there's a shortcut that if I were to give you another one and I had 5 powers in there, do you think there's a shortcut you could do to get from the first column all the way to the last column without having to do the 2 middle? If you said add the exponents of the powers being multiplied, you're right. We can do this table every single time. Anytime you're multiplying powers, if you need to do it, go for it. But there's a shortcut, and that's our product of powers rule. When you multiply powers with the same base, and I need you to underline, write that in capitals, highlight, box in, whatever you need to do. The base has to be the same. We just add their exponents, okay? So look here. Both of these have a base of a. So I'm just going to add m plus n. Now in this example, I can't. I don't know m, I don't know n. That's how you write it. Leave it alone. That right there is the product of power rule. That's your formula, basically. Now, if you look here, you have 2 squared times 2 to the 6th. That's 2 to the 8th. I also wrote 256 because here's why. If you're told to simplify, you actually have to do as much as you can do. Remember, we've been going through this every video. Simplify means go until you can't go anymore. Well, I can do 2 to the 8th, okay? Now, when it comes to the x, I can't do x to the 12th. I have simplified it by adding 3 and 9. Let's go do some examples, and there's some different instructions. So we're at a point where you have to read the instructions because it's going to tell you something different. And here's what I mean. This just says write each expression using each base only once. Nowhere in here does it say simplify. So don't freak out that you see 12 to the 4th times 12 cubed. Here's what we do. Same base. Add the exponents. You get 12 to the 7th. Now, is that only one base? So you have done what the instructions have said. Okay? Now, I'm going to stop for a second on the exponents and touch on the parentheses here with the negative. Having a parentheses inside versus outside completely changes the value on some cases. So what I need you to understand is if the problem starts with parentheses and the negatives inside, when we go and rewrite it, you got to keep the parentheses with the negative inside. Add your 2 exponents. So this goes back to your integer rules. There is a video as well if you need that to practice. But -2 plus 7 would give you a +5. Don't change your base. Your base has to say exactly what it was, always. Okay? So you should know by now, it's your turn. Pause the video. Try these on your own. Let's see how you did. Remember, as long as the bases are the same, we can do this. On my first one, both bases are 8. So I'm going to write it as the same base and just add the 2 exponents. So you should have 8 to the 9th. Here with a decimal, I would use a parentheses just because some people's handwriting and all this just starts getting kind of wonky. So rewrite it. Now be careful here. I am adding 2 negatives. When I add 2 negatives, it's just going to give me a bigger negative. Some of you might have put 1 over 0.5 to the 11th because of our negative exponent rules, which is fine. Both of them are acceptable. This just didn't say simplify. So you can leave it this way, you could put it that way. Last, now I have 3 powers. Doesn't change anything. Okay, this time I'm just going to write the base since it's all the same. And I'm going to add the 3 exponents. -3 plus 2 is a -1, plus 6 is a +5. So in these examples, you're done. All it said was using each base only once. We were just practicing the adding. Now we're going to come into the simplifying. Okay, there's a couple things going on here. Let's look at the first one. I have 4z to the 5th times 9z to the -12th. Now, 4 and 9 aren't the same base, but that's okay. I can use my commutative property, move things around. You've been doing 4 times 9 since elementary school, so we can still do that. The new thing here is that I had the variables with the same base. So I have the z's. So I'm going to do 5 plus -12. Well, we know 4 times 9 is 36, and 5 and -12 is -7. On this example, we cannot leave it here, and here's why. The instruction said simplify. So I must make that negative exponent positive by moving that to the bottom. Now, I want to emphasize something here. That -7 is only on the z. It's not touching the 36. So the 36 stays put. Okay? This here is your final answer. So let's go over this next example. And be careful here because I've got 3 powers, but now I've got different variables. So here's where that commutative property is super important. Rewrite it. Put your numbers with numbers. A's with A's, B's with B's, and whatever you might have. Organize it so you can focus on one thing at a time. So you can then group and add your exponents at the top. You don't have to, you can do that mentally in your head. But you do need to do 2 times 9, which is 18, times 3, which is 54. I add 1 and 2. Okay. Now, technically at this stage, that's the right answer, but we write it without those multiplication symbols in between. When you have a number and you have a variable and it's being multiplied, we write it all as 1. Okay, you know what time it is. It's your turn. So pause the video now. Try these on your own. And then, of course, we're going to go over them. Okay, let's see how you did. Again, my advice is reorganize them. Numbers with numbers, x's with x's. Okay, so 4 plus 9 plus 1, right, gives you 14, and then 5 times 3 is 15. Okay, now this might get a little tricky, so don't automatically look and say, oh, it's a negative exponent, I'm going to have a fraction and all this. You first need to rewrite it. Because if you notice you're doing 3 plus negative 2, that exponent becomes a positive 1. So sometimes we need to do this adding of exponents before we worry about making something a positive. When I multiply, I should get negative 56. C d squared. Now that negative is going to the 4. Okay, don't give it to an exponent. If an exponent's negative, it'll be up smaller with the exponent. We got to look at what's given to us. Don't rewrite it, don't change it, don't make something up. Last, we have our last example. Let's rearrange it, okay, so that I have 12 times j and 2 plus 1, and then k to the negative second. So when I add, I get 12j cubed, k to the negative second. Well, you've done the negative exponent topic, so I cannot leave that. My instruction says to simplify. And we make a negative exponent positive by putting it on the bottom. You have to keep in mind, if something is getting that negative exponent, it's right on it, it's touching. So the only thing here that gets moved is the k. The 12j cubed was all positive. It stays on the top. Okay? How'd you all do? Good. So if you have not subscribed already, subscribe below. And here's my advice. If there is a topic, if there is a question that we're covering or that you see moving ahead, working ahead, even in Algebra Nation if you've worked ahead, comment below. Tell us what it is. Post a picture of it. I can do a video on how to do that type of problem. Okay? So if you have any questions, don't hesitate to comment. And always take time to reflect and summarize. That definitely helps.